Alright, so this is basically lecture 7A. So we're gonna talk about chemical bonds, like ionic bonding first, okay? So first and foremost, what is the different types of chemical bonds? So we have four different types. First, we have metal with non-metal, that's typically ionic bonding. Metal with metal is called metallic bonding. Non-metal and non-metal is covalent. And hydrogen with non-metal is typically a hydrogen bond. So first and foremost, what is a ionic bond? So an ionic bond is basically where a transfer of electrons from one atom to the other. So for example, you have an element like NaCl, which is sodium chloride, right? So Na, we know that is a metal in group 1. It loses its electrons to form a positive, and that electrons actually travel to chlorine. And remember chlorine, which is in group 17? It actually gains the electron, turns into a negative, and actually stabilizes its full outer shell of electron configurations. Therefore, it actually becomes stable. Okay, so this is another example down here. You can see the formation of ionic bonds typically from, you know, the transfer of electrons. So you can see down here in the third shell down here, you can see how we have one electron. That metal actually loses the electron and gives it to the other element down here, which gains the electron. Okay, and now they are stable now. So the formation of ionic bonding, right? For example, if you have NaCl, typically they are like together, right? So why are they together? There is this force called the electrostatic force. So the special thing about the electrostatic force, right, is that it actually combines or kind of like bonds these two elements together between the positive charge element and then the negative charge element together. So it's the positive charge is actually what we call the caution, and the negatively charged is what we call the anode. So the formation of ionic bonds, typically, we have the alternative positive and negative ionic in the ionic compound solutes that are basically arranged in orderly way as well. You don't really need to know this, but it's just something I want to spit out there. Okay. So if you remember the last lecture, I showed you the difference between non-polar covalent bonds and polar covalent bonds, right? So this time, you can see that if you have an electronegative difference of 1.9 and above, is typically an ionic compound, for example, like NaCl. Okay, so just make sure to internalize this. So the properties of ionic compounds, like I said, melting and boiling point, as well as your electrical conductivity. So the thing about it is, right, the melting and boiling point of ionic compounds are high, essentially because the large amount of thermal energy that is actually required to separate these ions from each other, right, are actually held together by these strong electrostatic forces. And these strong electrostatic forces are also known as the electrostatic force, right? And in order to break that electrostatic force, or I mean, if I'm not sure, but it should be the electrostatic force or the intermolecular force, either one of those. If both of them have a very strong bond, right, it requires more energy, therefore having a higher and melting boiling point, requiring a large amount of thermal energy. But if you have an element, or you have a weak electrostatic force, as well as a weak intermolecular force, right? Typically, you don't really need a lot of energy to break the bonds, therefore, having a low melting boiling point and needing a lesser amount of thermal energy to break the bond, okay, to separate them lah. And this also goes to the electrical conductivity as well. Typically, if you have charged particles that are not floating around because they are not broken down by the actual bond itself, right? They do not conduct any electricity. But if you were to melt and boil those elements, right, it actually allows those charged particles to roam around freely, therefore having to able to actually making the element able to conduct electricity. Okay, so that's electrical conductivity as well. So we can read here more for electroconductivity. Solid ionic compounds do not conduct electricity because there are no mobile charged particles floating around, unlike metallic compounds. Metallic compounds are like metal, so they are very good properties of conducting electricity and heat. Ionic compounds can conduct electricity in molten. So molten basically means that they already have been melted down to lava stage already. Because when you melt an ionic compound to lava stage, right, it actually allows and already has broken the bonds. Therefore, those charged particles actually to roam around freely, making it able to conduct electricity. And that's all for lecture 7a.